Welcome to another physics class. Today we are going to look at power. During our last lesson, we done everything on energy. So today is power. Then what are the possible definition of power? Definition of power. 1. Power is the time rate. Is the time rate of doing work. That's the first definition of power. 2. Power is the ratio of energy transferred to time taken. Number 3, power is the ratio of work done to time taken. These are the various ways in which we can define power. Mathematically, from all these definitions, power is equal to energy transfer over time taken. Or we can say power is equal to work done over time taken. That's the formula for power. The unit of power are 1. Watt. 2. According to this formula, one's work is joule and time taken is second. So that one will be joule per second. That is joule per second. You can still get another unit from work done over time taken. From this work done over time taken, since power is equal to work done over time taken. Then you can now say work is equal to Fs, that is over time taken. Because work is force multiplied by distance. So if work is force multiplied by a distance, then another unit now can be Newton meter per second. Newton for force, meter for distance, and second for time. That's another unit of power. So power can be other unit of power can be 1, 2, 3, that is 4 kilowatt. That is 1 kilowatt, 1 kW is equal to 10 raised to power 3 or 1000 watt. 2 megawatt. 1 megawatt is equal to, that is 1 million, 10 raised to power 6 watt. Another one That is 1, 2, 3, 4, 5. That's number 6. That is gigawatt. That's GW. And 1 gigawatt is equal to 10 raised to power 9 watt. And the last one, which is still unit of power, that's number 7, is horsepower, HP. And 1 horsepower, 1 HP is equal to approximately 750 watt. 1 horsepower is equal to approximately 750 watt. These are the possible unit of watt. At the same time, power is a scalar quantity. Don't forget, when you say scalar quantity that has only magnitude without a specified or follow a specific direction. So these are the general properties of power. The next thing is relationship between power and speed of an object. That is, we want to see how the power can be related to speed of an object or velocity of an object. Now, we've said that power is equal to work done over time taken. Now, from there, we can now simplify further that since power is equal to work done over time taken, we can now say that this one can now give us force multiplied by distance over time taken, since work done is force times distance. So from there now, we can now say, but from linear motion, speed V is equal to distance over time. Therefore, you can now say power will be equal to, since this one is distance over time, that's F multiplied by V. So this is where we got the unit as power. The unit of power as Newton meter per second. That is this one for Newton, then velocity or speed for meter per second. And rather, from here also we can get the basic unit of power. All the units we've mentioned the other time. For instance, this is the SI unit. Joule per second is the derived unit. Another derived unit is Newton meter per second, as we said here. But within all this one now, we need to write the basic unit of power. And we can only write the basic unit of power from this one. That is from power, basic unit of power. So from this point, we can now express further until we get all this quantity as fundamental quantity. So we can now say power as force multiplied by distance over time taken. So from there now, our force is ma, then that is over multiplied by d over time taken. So from there now, we can now have the power as A is what? Velocity over time again. Then another time is there. Expressed further, we are going to have power is equal to m, velocity is what? Distance over time taken. So that will be distance multiplied by distance over time. So from there now, we can now have power as mass in d square over t cube. So from there now, we can now get the basic unit of power as basic unit of power now. That one will now give us this one for kilogram, that is for mass, distance for meter square, then time, that will be the basic unit of power, that is kilogram meter square per second cube. That's the basic unit of power. And if you count the number of units now we got for power, that is 1, 2, 3. All this one another unit that we can still measure 4. So power have 4 major units. That is watt, joule per second, Newton meter per second, and kilogram meter square per second cube. Those are the 4 major units of power. Let's take this one as example 1. A water pump raises 400 kilograms of water to a height 15 meters in 20 seconds. Calculate the power of the pump in kilowatts. So solution to this one, let's first write out the parameter. Mass of the water raised is given, that's 400 kilograms. Height is given, h, that's 15 meters, and time is given, that's 20 seconds. We now have to calculate power. And according to the formula given, power is equal to work done over time taken. And this work done is, according to the question, is form of potential energy. That will be mgh over time taken. M is given as 400. G is given, according to the question, 10 meters per second squared. Then that one will now give us 10. Then the height is given 15. Then over 20. So continue with this one. The power now will be equal to 0, we cancel 0. And this one will cancel this one. This one will be 200 multiplied by 15. And this one will now give us 3,000 watts. But the question says we must calculate in kilowatt. So take 3,000 watts to kilowatt now divided by 1,000. So our P now in kilowatt now be equal to 3,000 over 1,000. That will be in watt. So the power now in kilowatt will be equal to 3 kilowatts. That's the solution to the question. Now, let's take this one as example 2. A racing car pushes against air resistance with a speed of 75 meters per second. If the thrust of the engine is 2,000 Newton, calculate the power of the car. Solution to this one, let's write out the parameter given. Speed is given. V is equal to 75 meters per second. Then thrust, that is another word for force. Force is given as thrust, that's 2,000 Newton. Now we have to calculate power now. According to one of the formula written the other time, so power is equal to force multiplied by speed. This one will now give us 2,000 multiplied by 75. And power of the car will now give us 150,000 watts. That's the power of the car. Let's take this one as example 3. A man of mass 75 kg expands energy at the rate of 200 watts in ascending a vertical height of 44 meters. Calculate the time taken to ascend the height. G is equal to 10 meters per second squared. To solve this one, let's first write out the parameter given the question. Mass of the man is given 75 kg. Then the rate at which it expands energy, that is power, without wasting our time from the definition. That's 200 watt. Then the height that the man is ascending is given h, that's 44 meter. So t is what we have to calculate. And g also is given 10 meter per second square. Now, don't forget our formula. Power is equal to energy transfer or energy expanded. That is energy expanded according to the question over time taken. And from there now, the power is given. Then the height also is given. So this one will now be power will be equal to mgh over time taken. Mind you, we need time. So let's make t the subject of the formula. So from there now, pt now will be equal to mgh. T now will be equal to mgh over p. So substituting all this value now. Mass is 75. G is 10, height is 44, and power is 200 watt. So, cut this one, 0 will cancel 0, and that will be 2 here, that is 10, 2 here, that's 22. So, time now will equal to 75 multiplied by 22 over 10. 75 multiplied by 22 over 10. Time now is equal to 1650 over 10. Then the time taken to ascend the height will be equal to 165 seconds. That's 165 seconds. Let's take this one as example 4. A pump is used to spray water from a pool in order to form a fountain. If the pump ejects 50 kg per minute of water through a vertical height of 4 meters, calculate the maximum power of the pump. Now, solution to this one. Solution. Let's write out the parameter given within this question. Mass is given 50 kg. Indirectly, time is given. Time, that is 1 minute. That is 50 kg per minute. So 1 minute will be equivalent to 60 seconds. Then height is given. That is 4 meters. At the same time, G is given. Then that one will now give us 10 meters per second square. We now have to calculate the maximum power. P now, maximum, will be equal to mgh, that is energy transfer over time taken. So M is known, that is 50 multiplied by 10 multiplied by 4 over 60. So from there now, 0 will cancel 0. Then we are going to add the maximum power. That P now will be equal to 0 will cancel 0. That's 50 multiplied by 4, then over 6. So from there, we can now have power will be equal to 200 over 6. So maximum power will be equal to 33.33 watts. That's for example 4. Let's take this one as example 5. A spray is used to spray water from a pond to a fountain. Calculate the 1. Power of the engine when the work done by the pump, is 800 Newton meter at 50 meter per second to a distance of 20 meter. Second question, 2. Mass of the pump when the water is projected at an acceleration of 10 meter per second square. Now, let's tackle the first question under this one. Power, let's write out the parameter. According to the question, work done is given. That's 800 Newton meter. Then, V, that is the speed, V is given 50 meter per second. Then, distance, D, is equal to 20 meter. From this one now, you know that power is equal to work done over time taken. Work done over time taken. And from there, here, work done is given as 800 Newton meter, 800 Newton meter. Now, speed is given 50 meter per second. Then distance is given 20 meter. So we need time now. So we need to look for time. So we'll be able to calculate power. So now say, first, calculate time. Now, we can now say, since distance is given as s from linear motion, you know that s is equal to v plus u over 2 into bracket t. V plus u over 2, that's the distance covered. That's from linear motion. Now, a spring is used to spraying water. It means the spraying machine will have initial velocity. U will be equal to 0. If u is equal to 0, then we are going to have s, which is our distance. I mean d, let's use d according to the question, as distance cover will be equal to v over 2 into bracket t. Since u is equal to 0, because the spray machine will have initial velocity. So from there now, we can now say 2d, that is the distance, is equal to vt. T now is equal to 2d over v. So what is our d? That's 20. That's 2 multiplied by 20. Okay, our v is what? 50. That will be 40 over 50. And this one will now give us our time is 0.8 seconds. If time is 0.8 seconds, then we can now come back by saying power be equal to 800 over 0.8. And the power of the pump will now give us 1000 watts. That will be the power of the pump. Question to calculate the mass. Mass. Now, to calculate mass, already we know that our power is equal to F multiplied by V. That is force multiplied by velocity or speed. And we've already know the value of power as 1000. But from the question, F is not given. So we can now substitute. You can now say, but F is equal to mg. So from there now we can now say that P will be equal to mgv. We need mass. So our m now will be equal to P over GV. According to the question says it is being projected at an acceleration of 10 meters per second square. So that one will now give us 1000 divided by 10 multiplied by 50, which is given speed. So that is, this one will now give us 1000 over 500. And the mass of that form will now be equal to 2 kg. And to this end, we come to the end of the lesson for today. And by now, we've talked lengthily on work, energy, and power. But if you still have questions on any of the topic, you are free to ask your question from the link under the channel. And mind you, if you are just joining us, for you to understand the topic better, please try to like, share, and subscribe. And make sure you watch our former video so that you can understand the lesson. Thank you.